Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Loopy Entropic X-Sums by Yitrio. And here are the rules. We have normal Sudoku rules apply, which means fill every cell in the grid with a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region. In this case, a box. We also have to draw a 1-cell wide loop of orthogonally connected cells. The loop may not touch itself, not even diagonally. So what does it mean to make a 1-cell wide loop of orthogonally connected cells? That means on the loop, you have to be able to, every cell on the loop must share an edge with exactly, I'm trying to figure out a loop that works. Must share an edge with exactly 2 and only 2 cells on the loop. And they cannot be touching diagonally with any other cell on the loop, aside from the 2 cells it shares an edge with. So this is a valid 1-cell wide orthogonally connected loop. This would not be, because this would essentially be considered touching itself, right? It's touching itself diagonally. This also would not be, because it would be touching itself orthogonally. But yeah, so a valid loop is something like this, right? Because every cell on the loop shares an edge with 2 and exactly 2 other cells on the loop. And that's how orthogonal loops work. The loop acts as an entropic line, where each set of 3 adjacent digits along the loop must be 1 low, 1 medium, and 1 high. So you could have something like 6, 7, 1 here, and that would be valid because along this stretch of 3 digits on the loop, adjacent digits on the loop, we have 1 low, which is the 1, 1 medium, which is the 4, 5, which is the 6, and 1 high, which is the 7. So that's how entropic lines work. And that's for any set of 3 unique digits, 3 adjacent digits on the line. Clues outside the grid are loop cell X-sums, and they indicate the sum of the first X digits on the loop in that row or column, where X is the digit next to the clue and not necessarily on the loop. X cannot be larger than the number of loop cells in the row/column. So, for example, you could have this being 1, right? And this being value of 4. And that would be valid, because if that were the case, you would look at the first X digits on the loop in that column, which would be, and that would be just 1, because of the X being 1, and that would equal 4. Another way you could have this too, though, is if this is 2, and this is like, say, 1 and 3 here. We can get it eventually in the right square. Yep. That's saying that the first 2 digits on the loop in that column must sum to 4, and it does, because we have 1 and 3 on the loop, adding up to 4. And those are the first 2 digits. What you could not have, first of all, you can't have 5, so therefore that's greater than the number of digits on the loop in that column. And you couldn't have 5 anyways, but you couldn't have something like 4, because the 4 unique digits could never add up to 4. So that's what the clues outside the grid are. They are loop cell X-sums. And again, the X is the first digit seen in the row or column, respectively, and it may or may not be on the loop. Anyways, those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so since we know these are all x sums of digits on the loop, how many digits can you have that add up to 42? What's the minimum? What's the maximum? It has to be 7 or 8. Because 7's minimum. You could have the digits 3 through 9, which is 7 digits, adding up to 42. Or it could be 8 digits, right, with the digit removed being a 3, right? You could have 1, 2 with 7, 3, 4, with 4 through 9, adding up to 42. Whatever it is, we know at least 7 digits here are on the loop. So this must be on the loop because it can't be excluded. So this is on the loop, which means both of these are on the loop because those are the only two cells it can share an edges with. This cannot be on the loop because it would be touching itself. So it must go here and it must go here. So these three are on the loop. These are not. This is 1 or 2 here because either way, if this is 1 and we're on, because to add up to 4, you can only have 1 unique digit or 2. To add up to 8, it's a 1, 2, or 3. To add up to 24, it's at least 3, at most 6, right? If you tried to have 7 digits adding up to a sum, that would add up from 1 through 7, which is 28. So this is also 3 through 6 for the 21. The 12 is either 2, 3, or 4. Okay. If this were 2, it could not be on the loop because it would be 2 and 2 adding up to 4, which is not allowed. If it's 1, it would also not be on the loop. So this can never be on the loop, period. Exactly. This is what I guess we're saying. That means we're missing a 1 or 2. We must be missing another 1 or 2 here, which makes this 7. So we have 7 digits on the loop. We're missing a 1, 2. We must be missing another 1, 2 in this row. Or the 1, 2 could be on the loop and it's the first 7 digits. That's also possible. So it must go in here. So that means it cannot go here because if it goes this way, that would touch itself here. So the loop must look like this coming in. And then going out, it would have to be like that. So this is not on the loop. It has to go here. Just could go this way, so we don't know. This can't be on the loop because it would be touching itself there. This is on the loop and it includes itself. So if it were 3, that would not work. Therefore, this is 4, 5, or 6. That means one of these is 1, 2, or 3, and the other is 8 and 9. This must be 4, 5, or 6 because it's on the loop. It's the same entropic set as this one. Because on an entropic line, you'll always alternate between 3 digits, 3 sets. And you'll always lose one set in the next set of digits. So this one must match that one because it must match that set. One of these are 1, 2, and 3 because these are 1, 2, 3, 4, 5, 6. Because of the entropic lines, one of these is low, one of these is low. Therefore, we know the rest of the row cannot be low. So these are 4 through 9. So we know that these, we have a problem. Can this be 3? No, it just can't be 3. right, we have a problem. Yeah, this doesn't work. How does it not work? Hmm. Okay, what am I missing? Oh, first 7 digit. Right, never mind. It does work. So all of these must be on the loop. This can't be 7. All of these have to be on the loop then. And we're counting the first 7 digits. So this cannot be 1 or... This then must be the other 1 or 2 because we're counting the first 7 digits. Therefore, this must be 3. This can't be 1, 2, or 3. This is 8 or 9. Therefore, this is 1 or 2. So we're missing the first... we're counting the first 7 digits on the loop. This doesn't have to be on the loop, actually. But this does have to go here, fills out all these. These add up to 42. And 1 or 2 is not added to that. So this is 3. This is 1, 2. So this must be a high. So this is 7, 8, 9. This must be 1, 2, or 3 here. This is 4 through 6. This cannot go this way, so this must go this way. So this is on the loop. It cannot be 2. If it were 2, then it would add itself another digit, which would have to be at most 9. 2 and 9 does not add up to 12. It adds up to 11. And this has to be low, so this must be a 3, actually. What else do we have? Oh, this is a loop. It could be the first digit here, right? Yeah, so that's not guaranteed there. If we try to go green, green, that would not work because the minimum then would be 4 and 7 because of the entropic nature of that. But you could go here and then here. That's possible. Not helpful, but possible. Okay, so what happens if it's connected here? If it's connected here, this would be a medium. This would be high. So if we connected here, this would be medium to match this. Because every third digit on an entropic line is the same set. Middle, this would be high. This would have to be low, which is not possible. So this cannot connect this way. Therefore, this must go this way. Therefore, this cannot go this way. So this is not on the loop. Must go this way. It's a high digit, so it's 7, 8, or 9. So this is medium. That means the remaining digits are low or high. If this goes this way, this is high. If it connects here, then, so if it connects, okay, so high, low, medium, high, low. So it cannot connect this way, right? We know this is medium. We know this has to be low because of the 7. The first 7 has to add up to 42. So this must be low. This then must be low. This is medium. If it goes this way, this would be high, low. Okay, this cannot go this way. These can't go this way because it can't touch itself. This must go there. So if it connects here, medium, medium, high, low, medium, high, low, which is not allowed. So it cannot connect here either. So this must continue on going that way. This cannot go this way because it would touch itself. So it has to continue going that way. This has to, actually, this could go back. This could double back. And in fact, it probably does have to double back. The first 3 digits, this is a high digit. So it cannot go, it could go here, because then that could be 371. But if that were the case, so what happens if it goes that way? Okay, so this is, these are both medium and high, so this has to be low. Therefore, this is low. This cannot be low. This is medium. This is low, so this is 1 or 2. This is medium, so it's 4, 5, 6. This must be low, so it's 1, 2, or 3. That makes this. So we need, so it could be low here, medium. Okay, the remaining digits in row 2 have to be 4 through 9. Because we have a 1, 2, 3 triplet already there. 7 cannot be here because of the 7 in the box. This cannot be 9. Okay, say we didn't go this way. If we did not go this way, this would have to be a medium or high, and this would have to be medium or high, and the first 3 digits then would never add up to 12. So then it must go this way. This is a low. It's 1 or 2. So we have 3, 2, 7 adding up to 12, or 3, 1, 8 adding up to 12. This then connects here, so none of these can be loop cells because it would be touching itself. This is medium, so it's 4, 5, 6. This is high, 7, 8, 9. This can't be high, so this is medium, 4, 5, 6. This is, well, we sort of already knew that. Okay, so this is 8 or 9. This cannot be 4, 5, or 6 because of the 4, 5, 6 triplet in the box. Therefore, this is 7, 8, 9, which forces this to be the low. That's 1, 2, 3. This is 7, 8, 9. We don't know which one's left. Okay. This has to have, this is either 4 or 3 because those are the number of cells on the loop possible. That means if it's 3 and this is on the loop, it can't be 3. It'd be, if this is on the loop, it has to be 4. So it has to be these 2 cells on the loop, which makes this, right, it would have to be all 3 of these cells on the loop. If this is not on the loop, that means it would have to be 3, and these 2 would then be on the loop. So either way, these 2 are always on the loop. It must go down here to connect. This can't be on the loop. These cannot, this one specifically can't be on the loop. It could enter this way or enter this way. So it enters either going this, so this can't be on the loop because it can't enter and then exit. It could go something like that, or it could go something like that, or it could go something like that. We don't know. Ah, that's interesting. If it went on the loop here, so continued on, this would be high and this would be low. So this would have to be 3. But that doesn't work because it would be on the loop and 3 digits with a 3 adds up to at most 20. So this cannot be on the loop, which means there's 3 total on the loop. So this is 3, which forces this to be a, wait, that doesn't add up. That adds up to 7, 8, and 9. Oh, I see. No, it doesn't go this way. We know these 2 are definitely on the loop. If we try, so that doesn't work either way this way. If it tries going on the loop here and then going that way, it doesn't work. If it tries going on the loop this way, it doesn't work either. This can't be 7, 8, 9 as a triplet to add up to 24 because these would both be high. So this must be on the loop. It must be 4. And therefore, because of that, this cannot connect this way. So it must connect this way. Clever, actually. That means this can't be 4. These are not on the loop. It must exit out this way. It cannot go here, so it must go on the loop here, which means this can never be a 1. This is a low. So we've got middle, this is high, 8 or 9. This is low, 1 or 2. Middle, 5 or 6. High, 7, 8, 9. Low, 1, 2, 3. This is high, 7, 8. Can't be 7. This is 8 or 9. So this is 2 or 3. That matches. So this is 4 digits adding up to 24. So 3 digits add up to 20, must add up to 20, which is 24 minus 4. So this is 3, and it must be an 8 and 9 pair. This is 1 or 2, therefore this must be 2 digits adding up to 4. So this is 2, which makes this 1. That makes this a 1. So this is what? 3, 1, and 8 adding up to 12. This is, yeah, 3, 1, and 8 adding up to 12, which makes this not 8. That's 9, which makes that 8, which makes this 9. That means this can't be 8, so this is 9, which makes that 8. None of these can be, this can't be 9. No 7, 8 then in the rest of the row. This can't be 8 either. Where is the 8 in box 1? Can't be here. Can't be here because of the 7, 8 pair in the row, so it must be here. So this is 8. We have a 4, 5, 6 triplet in row 3, which eliminates 4, 5, and 6 in the rest of the row. Therefore, one of these is a 4, and this can't be 4. We have the remaining digits as 1, 2, 3, 7, 9. But it can't be 2. So 1, 3, 7, 9. No 1 here. This cannot be 3 because the first 2 digits in column 6 must add up, in the loop, must add up to 4, and that's 1 and 3. So this is 7 or 9. We have a 7, 9, 7, 9 pair in row 3, which eliminates 7, 9 in the rest of the row and in the rest of box 2. So this can't be 7 or 9. This can't be 9. Therefore, we have a 4, 5, 6 triplet in, well, yeah, this can't be 2. This is 1 or 3. Yeah, this matches. Okay, so that's good. We have 21 in column 8. Again, it cannot be 3 or 4, so it must be 5 at least. And it must be 5 exactly because that's the maximum that's a maximum number of cells on the loop you could have. So this must be 5 then, which means this can't be 5 here. That makes this a 4, 6 pair in row 3, which eliminates 4 and 6 in the rest of the row. This can't be 6, this is 5. So none of these are on the loop. None of these are on the loop. To connect back, you have to go here. You must connect here. Okay. This can't be 5. This can't be 5. This must be a medium. It's 4, 5, or 6. This is low. 1, 2. Can't be 3. This is high. 7, 8, 9. Medium. 4, 6. Low. 1, 2, or 3. This is high, which makes this a 7 because it can't be 8 or 9. This is medium, 4, 5, and 6. So this cannot be the last one in this column. Can you ever exit out and then go back? No, because then it would touch itself. So it must continue down this way. And this is a low. So none of these could be lows if they were on the loop. So these cannot be on the loop. So it must turn here. And this is a 3. Oops. Why am I clicking that? 3. There we go. To add up to 4. This adds up to 21. Okay. That means the other 4 digits must add up to what, 16? No, yes, 16. What's the minimum already? 4 and 8, which is 12, plus 1 and 2. Okay, so this can never be a 6. If this were 6, this would be at minimum 6, 8, 1, and 2. That adds up to 17. 17 plus 5 is 22, which is greater than that. So this can't be 6. This is 4. I think this always has to be 3. Right? No, this could be 9. 9, 1, and 2 works too. So 21 minus 4. Okay, this can't be 1 anyways because of the 1 in the column. So this has to have a 1. It's either 1, 2, 9 adding up to 12 or 1, 3, 8 adding up to 12. We don't know which. 4 and 5 can't be here in column 8 anymore. So this must be a 6 here. And we have 7, 8, or 9. It cannot be 8 or 9 because of the rest of the 8 or 9 in the box. So this must be 7, which means this can't be 7. This has to be 8, which makes this 7. That means this can't be 8. This is 9, which makes this a 1, 2 pair. This 1, 2 pair to add up to 21, right, for the first 5 digits in the loop. So 4 and 5 adds up to 9, plus 1, 2, 9 is 12. That 9 plus 20, 12 is 21. So this can't be 2. This is 3, which makes this 2, which makes this 1, which makes this 2. This 1 eliminates 1 here, so it's 3, which makes this 1. This can't be 6 because of the 6 in the box, the 6, 7 pair specifically in the box. This must be a high digit, 7, 8, or 9. Okay. I don't think this is ever 3. If it's 3, it would, yeah, it just doesn't seem to, I guess, no. Could it be? Maybe. No. I'm pretty sure it can't be 3. If it's 3, it would have to be with 1 and 4 adding up to 8, add up to 8. I guess 1 and 4 could be different ones. Okay, how would that work? If this is 3, you would have to have 1 and 4, so it would have to be 4 here if it's going that way. I guess it could be something like weird like that. That's possible. So this would be low. 1, 2, low. That would be possible. But the next digit could be, yeah, so 3 could work actually. Yeah. So 3 is viable. 2 could work with 6. And what are the possibilities? Okay, let's look at the possibilities for the rest of column 1. We have what? 2, 3, 6, and 8. But 8 cannot be here because of the 8 in the box. This can't be 3 because of the 3 in the box. So we know in column 1, 3 has to be here. 8 also has to be one of these 2. So this is 2, 3, 6, and 8 as possibilities. So this cannot be 3 here. That's interesting. That means if this is 2, this is 6. Oh. It would have to go this way then, because that could not be on the loop if it's 2. If it's 3, this could not be on the loop because it would have to be, actually it could be 3, 4. But yeah, it doesn't work. Right? How does it get back on the loop? It doesn't really. Um, so it either goes, it's 2 here, which means this is 6, so this could not be 6 and cannot be on the loop, so it would have to go that way. It's 2 and 6. Or this is 3. It could not be 4 here and then 1 here. That's just not possible. And anyways, I don't know how we get on the loop back that way. So that doesn't work. If it's 3, it would have to go all the way around here. Which is possible. Yeah, and then you have a 4. So 1, 4. That's possible. Huh. Okay, so this is never on the loop. It's going one of those 2 ways. We're not sure which. Oh, these are no longer on the loop, possible. So this cannot be on the loop because it can't go here and then exit back out again. Could go here. That's fine. If we tried to go this way, and this being 1 and 4, the problem is to connect back here, this would be a high digit and would be next to a high digit, which is not allowed. So it cannot be 3, 1, 4. It has to be 2. So this must be not 1. This is 2, which makes this 6. This can't be 2 or 6, so this is 8. This is 3. Again, that's 3. We celebrate because we know we're getting close to solving this. That means this can never be on the entropic loop because it cannot be medium next. So it must go this way, which means this is 6. Since this is 6, that eliminates 6 here. This is 4. This is 6. None of these can be 6. This can't be 4, 5. This can't be 6, so this must be 9, which makes this 6. That eliminates 6 here, so this is 5. This can't be 5 or 6, so this is 4. This 6 eliminates 6 here, so that's 7. This is 6. The rest of Sudoku, we can sort of figure it out, I guess. Maybe, maybe not. Who knows? This is 2 or 9 in the rest of row 4. It cannot be 9 because of the 9 in the column, so this is 2. This is 9. The rest of box 4 has to be 1 and 7, so that's fine. That eliminates 1 and 7 in the rest of the row. This can't be 1. This is 2. This is 1. The rest of row 5 is 1, 2, 5, and 7. 2 and 7 cannot be here, so this is 1 or 5. This is 1, 4, 5 as possibilities, but cannot be 1 because of the 1, 7 pair in the row. And these can't be 1. Where is the 1 in row 5? It must be here. So this is 1. This is a 4, 5 pair. This can't be 2. The rest of row 6 is 3, 6, and 8. This can't be 3. This can't be 3. Where is the 3 in row 6? It must be here. So this is 3. Where is the 9 in column 6? It cannot be here because of the 9 in the row. Can't be here because of the 9 in the box. Can't be here because of the 9 in the row. And it can't be here because of the entropic part. So it must be here. So this is 9. This is 7, which means this cannot be 7 here. Where is... actually, that's not true. This is 2 and 6. The rest of column 2 is 1, 5, and 7. And this can't be 1 or 7 because of this 1, 7 in the row. So this is 5, which means this can't be 5. This can't be 8 because of the 8 in the row. This can't be 5 because of the 5 in the row. 6 could go to here as a high, as a 7. So 1, 2. So this would be, that's medium, high, low, medium, high, low. Okay, so that works that way. This 7 eliminates 7 here, so this is 9. Rest of column 9 has to be 2, 4, 5, and 6. But no 4s allowed in... Is it 2, 4, 5, 6? 2, 4, 5, 6, 8. Rest of the row box can't be 4 because of the 4 in the box. This can't be 2 or 6, so this is 5 or 8. This can't be 8, this can't be 5. So this can never be on the loop because it can't go straight there because that would be 2 away from another in the same set, and you can't go all the way around because it can't exit out again. Cannot go here because it can't exit out again that way. So it's either 1, 2, 3 or 1, 2, 3. Or 1, 2, 3 or 1, 2, 3. Okay, remaining digits in column 3. We have 1, 4, 7, and 9. 9 cannot be either of these. This can't be 4. We actually have a 1, 7 pair in box 7, which eliminates 1 and 7 in the rest of the box. This can't be 1 or 7. This is 4. This can't be 1 or 7 or 4, so this is 9. The 6 eliminates 6 here, so this is 8, which makes that 6. That means this can't be 6, so that's 4. The rest of row 8 is 2, 5, and 6. Well, this can't be 2 because of the 2 in the column. This is 2, 5, or 6. That's fine. We have a 4, 5, 6 triplet in column 7, which eliminates 4, 5, 6 in the rest of the column, so this must be a 3. Remaining digits in this 4 eliminates 4 here, so this is 5, this is 4. The 5 eliminates 5 here, so it's 7, which means this can't be 7. That leaves this digit as an 8 in column 6. That eliminates 8 from the rest of the column, or the rest of the row, so this can't be 8. This is 5. This can't be 5, it's 4, which means this can't be 4, it's 6. That means this can't be 6, it's 4. Which makes that 5, and that is 6. This can't be 5 or 6, so this is 2. That leaves this as an 8. This can't be 2 or 6, so this is 5, which makes this a 2, which makes that a 5. Where's 2 in column 5? It has to be here. So this is 2. Okay, this is a 4. It cannot go that way. This must be a 1. That's a 7. Again, it cannot go that way because these are the same set. It must be a high digit. That means it goes that way. It's a high. So this becomes 7, and this is 1, and it connects this way. And this is the loop, and the remaining digit is a 6. And this 1 eliminates 1 here, so it's 7, and that's 1. And that's a solution. Pretty cool, actually. Nice use of entropic lines and the loop cell xsums to restrict things. Very cool. I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.